A watched banana never boils.
Hola Fleetsters, welcome to another episode of Fleet TV. My name is Carla and I will be your host today. You might think that it's getting hot outside, but right here it's about to get really cold. How cold? Liquid nitrogen cold. To get things started, we're gonna send it over to our Fleetster in the field, Raiza.
Greetings, Fleet TV, and welcome back to yet another episode. Today, I am super excited to be introducing to you a new segment, and I am calling it the world's coolest cooking show. Now, I say it's a cooking show. You may notice in front of me that I have some food, but no implements of fire or knives or anything like that. And that's because today we're gonna be using a very special tool to be exploring with our food today. We're actually gonna be using something that makes up about 78% of our atmosphere around us. Today, we're going to be using nitrogen, and more specifically, liquid nitrogen. Now, anytime we're in a kitchen, we wanna be really careful about safety but because we're using liquid nitrogen today, we have to be a little bit extra concerned. So I'm gonna be rocking some super cool safety gear that I will put on through the magic of editing now. Last but not least, I have my liquid nitrogen itself. Now you'll notice that it is in a pretty heavy duty container, and that's because we need to keep this liquid nitrogen really, really cold in order for it to stay liquid. All right, now first things first that I have to do is make sure that I can get my liquid nitrogen from this container, this dewar that it's in right now, into a container that I can use to cook with it. So I'm just gonna really carefully take the top off it, and you'll notice right away that it looks like there's some sort of steam or vapor coming out of the top of the dewar. I want you to take a second while you're thinking about that and wonder why our dewar might look like it's got steam or vapor coming out of it. And watch very carefully as I pour. So what you're seeing happening with our liquid nitrogen coming out of here right now is that all of that liquid nitrogen that was very cold and highly pressurized inside our dewar is being exposed to the surrounding atmosphere and really, really rapidly forming water vapor. Now what's happening inside here is all happening at really, really low temperatures. Liquid nitrogen can get down to below 300 degrees Fahrenheit, so we have to be really careful with our gloves and our safety equipment when we're using it. But without further ado, I'm gonna be showing you exactly how you can do some really fun things with some food that you have in your kitchen, so let's get started. First things first, I think I'm gonna be experimenting with a banana today, seeing what happens when I try to use this as a smoothie experiment. So I'm going to be just topping off my liquid nitrogen really quickly. And then we're going to be making this nice and cold. So just a wee bit more in here. And then using my handy dandy tongs, I am going to be submerging this banana right inside my liquid nitrogen. While it's in there, I want you to think about what's happening to this banana. All right. So now that I have got one extremely, extremely cold banana, I am going to go ahead and see how best I can break it open for use in my smoothie or whatever project I'm taking on in my kitchen today. And to show off the differences between our super, super cold banana, I'm gonna use just a totally unfrozen banana that I just took from my bundle right here. And because The Emperor's New Groove is my favorite movie, I'm going to smash them with a hammer. So let's see what happens here. So I'm gonna smash our unfrozen banana first. Delicious. Yummy. Nothing super exciting, right? All right, banana smashing. 3, 2, me. There we go, that was a nice satisfactory thwack. So let's take a quick look at the difference between the banana that I smashed without liquid nitrogen and the one that I did smash with liquid nitrogen. You'll see that this one, still pretty goopy, solid, super delicious, but this banana seems to have actually shattered and splintered a little bit. Now, remember when I said that liquid nitrogen is really, really cold? Well, the temperature of that liquid nitrogen that I just had this banana submerged in is well under 300 degrees Fahrenheit, and bananas are made up of a lot of water. And what happens whenever we mix really, really cold things with water? Well, that water freezes, right? And that's exactly what happened inside this banana. This banana is about 75% water, and so the second I put it inside that very cold liquid nitrogen, all that happened was the rapid formation of a bunch of ice crystals that then made most of my banana nice and splintery. Celery next, shall we? see how a carrot will do. Oh, that was fun. All right, last but not least, we're gonna be seeing how our raspberries fare. Oh, that was fun. I promise I wasn't just smashing fruits and vegetables for fun there, although I do occasionally do that. What we were trying to show you today was this idea that anytime we've got a really, really cold substance, such as liquid nitrogen, it's gonna cause something called a phase change. And within our vegetables, our fruits, that phase change is gonna be of the water inside. The water that's just hanging out in its liquid form is gonna become solid because it's so cold. Or in the case of the liquid nitrogen itself, that's really cold, inside the doer is going to expand and form a gas out of its liquid form. So that's just a little bit of the cooking you can do in the world's coolest kitchen. I have been your host, Raiza and Julie. Go ahead and smash some vegetables, if you like. This is a mess.
Thank you, Raiza. That looked really, really good. So good that I just want to get it all into a blender and make a nice and delicious smoothie. I have a question for you. Do you know what snowmen wear on their heads? Ice caps! Yeah, that was a great one. I know. Anyway, instead of me being here and pretending that I'm floating in a cloud, I'm gonna send it over to Julie, where she has a really cool demonstration.
All right, hello everyone. Welcome to this episode of Fleet TV. I am Julie from the Fleet Science Center, and today we're going to be doing a really, really cool experiment. We've got this awesome chemical with us today in this container right here, and it's called liquid nitrogen. So it is the liquid form of the nitrogen that's mixed within our air. And when it's cooled down to really cold temperature, it can actually be in its liquid form that we're going to be playing with today. Now, because it's so cold, we do have to take some safety precautions. You've seen me wearing my really cool face shield here that we're gonna get down in just a second. And I've got my gloves and my lab coat on. So we're gonna go ahead and pour some of this out to see what it looks like. And you can see that as it pours, there's this cloud almost that's starting to form, right? What's happening is, as the liquid nitrogen is being introduced to the warm air, it's actually condensing the air around it and turning it into these water particles that you're able to see. Okay, so that's what's forming a cloud. So we're gonna take that and we're gonna put this metal bucket into our big one here, to our bigger red one. We're going to pour this bucket, like I said, into the bucket of liquid nitrogen, but we do need a countdown. 3, 2, 1. All right, so we got a pretty cool reaction going on here right now. You can see all of this amazing like cloud that's being made here. It's pretty neat. And again, this is the result of all of that liquid nitrogen kind of condensing the air around it. We sped up that reaction a lot by adding the hot water to the liquid nitrogen. The difference in the temperature is causing it to expand extra fast. And then it causes this really neat cloud effect that we're seeing. Whenever you see clouds up in the air on a cloudy day, this is kind of just a really sped up effect of that. So next time you go outside, you might want to think about these types of things that we see in our everyday lives. I hope you enjoyed this experiment today. Thank you so much for joining us, and I will see you guys next time. Thank you.
Now that is what you call disappearing in a cloud of smoke. Now, let's recap. Liquid nitrogen is negative 320 degrees Fahrenheit. And let's take a breath with me. About 80% of that breath that you took is nitrogen. Thank you for joining us again. Don't forget to like and share this video and follow us on all of our social media channels. We'll see you next time. Now, watch me disappear in a cloud of smoke.